Hello, Accelerated Math 7-8 students. We are starting a new module, finally, Module 13 and Lesson 1. This is our second experience with 8th grade standards. And what we'll be working with is number systems in this module, and the first lesson is called Exponential Notation. Exponential Notation. All right, so taking a look at these notes for exponential notation. Hopefully some of this is a review for you, and then we're going to just expand our knowledge and grow a little bit more. So, exponential notation is the title. The goal for today. Today we will learn the parts of exponential notation and important parts that allow it to work. The question that I want you to be thinking about during this lesson is, why should we use exponential notation? All right, under our things to know category. Exponential notation is the use of exponents when describing a number. It includes a base, an exponent, which is also known as the power. The base is the number that is being multiplied. It is the larger number when written. The exponent is the number that tells you how many times the base is multiplied by itself. This is the smaller number when written. The power is the whole thing. So it's the name of the base and the exponent when it's together. And so this whole thing right here is called a power, okay? We read this power that you see in front of you as 2 raised to the 4th power. And all of this should be a review for you. One thing that I want to do is the base is always the big number, okay? The exponent, just trying to give you some clarification and some stuff for you to remember, is the small number, okay? And then remember that this whole thing is called a power. This whole thing together is called a power. So on any standardized tests that you have to deal with and they say, what is the power that is being displayed, you need to remember that it's this whole thing. It's the base and the exponent together is called the power. Okay. So, what is the difference? Okay, we need to be able to identify the difference between these two powers that you're given. So this says, what is the difference between negative 3 to the 4th power and negative 3 raised to the 4th power? Okay, there is a difference between these two things. And I don't know if you remember, we've talked about it a little bit, but the parentheses are very important because they hold some identifying information when you're reading a power. Parentheses must be used when your base is a fraction, a decimal, or a negative. It prevents confusion about what the exponent is applied to. So when we have negative 3 to the 4th, it could mean you have a negative 1 times 3 times 3 times 3 times 3. And the reason why we see it that way is because the exponent is touching the 3. It's not touching a negative 3, it's touching a 3. Whereas in this one, we know that the whole thing is being raised to the power of 4 because it's inside the parentheses. So negative 1 times 3 times 3 times 3 times 3, which does not equal negative 3 times negative 3 times negative 3 times negative 3. So I'm hoping by me talking through this, you guys can understand the difference between the two. So parentheses have a major role. When they don't have the parentheses, the exponent only applies to the number that it's touching. When it does have parentheses, the exponent applies to everything inside the parentheses. So that's why we use them. Make sure to use parentheses whenever the base is negative, it is a fraction, or it is a decimal. You need to remember that. Okay? Product of factors. Product of factors means exactly what it says. The product of factors. So two numbers being multiplied together gives you an answer. So product of factors means when we're working with it in exponential notation, it means to write out the power showing what is being multiplied. So when you have a negative 3 inside the parentheses raised to the 7th power, your product of factors would look like it written out in expanded form. So whenever you see this sentence saying, please list the product of factors, this is what it's asking you to do. Take your base and multiply it by itself the number of times that the exponent says. That's what the product of factors is. So negative 3 raised to the 7th power means negative 3 times 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 negative 3. So we took negative 3, which is the base, and we multiplied it by itself 7 times because that's the exponent. Okay? All right. So then the next thing that you need to be able to do is you need to be able to convert bases, okay? And this can get kind of tricky if you don't pay attention, so I need you to really pay attention to this. All right, converting bases. Can you change 81 into a base of 3? So listen to my words and make sure you understand what I'm asking. Basically, it's asking you to say, is there a way that your base can be 3, and could you multiply 3 by itself until you get 81? So converting the bases is making you see if the base actually is a factor of 81, and if so, how many times? So if the number has a base as a factor, then yes, you can. And so we try it. We say, okay, how many times does 3 go into 81? And you do some math. So if we look at it and we take 81 divided by 3, we know that 3 goes into 8 2 times, and we know that 3 goes into 21 7 times. So does that mean that I have 27 threes? Okay, that's if you're adding them, yes, there are 27 threes. But if we're multiplying it, then we have to be very careful and say, okay, well, I know that 3 times 3 gives me 9, right? And then I know that 9 times 3, or I could even do 3 times 3 again because multiplication is commutative, so this would be 9 again. And then I know 9 times 9 equals 81. So the question was, how many 3's multiplied together, not added, multiplied together, give me 81? And there were 4 of them, okay? And so you're going to have to do this. You're going to have to find a base that would go into any number and then figure out if it can be multiplied by itself to get that answer, and if so, how many times? And that's how you figure out how to convert bases, okay? And that's about all that I have as far as the notes go for today. They were pretty quick. We are going to delve really deep into all of this stuff. There are some rules that you're going to be responsible for, and we're going to get to them as we progress through the module. I think you'll really like this module because it's very, very numbers oriented, like working with numbers and stuff like that. And it's fun. Things that you need to remember so that you've got your brain and your wits with you is we're going to be working a lot with negatives and a lot with positives, so you need to remember our negative rules, remember the helpful triangle, if that's going to help you, and all that kind of stuff. So let's go back to our goal. Our goal for today. Today we will learn the parts of the exponential notation, right here, and the important parts that allow it to work. We're talking about parentheses when we're saying the important parts. Why should we use exponential notation? I'm going to let you think on that a little bit more. There is a very specific reason why we use exponential notation instead of just multiplying numbers together, okay? All right, so be ready to discuss these, be ready to practice these, and I'll see you all tomorrow. Talk to you soon. Bye.